Let's go through question 5 now, and let's make it in two parts so that we can stay focused on shorter videos. So question 5, let's begin with part 1. We have a function f of x equals to ln of x plus 1 divided by x squared minus 1. The question is to find out the inverse and to find out the domain and the range of the inverse. Well, we will go through that later. We will find the inverse later, because we already know that the domain of the inverse is going to be the range of the original function. So for that, we must know in the beginning what is the domain of our original function of f of x and what is the range of f of x. Now, before going further, let's just remind something. Let's say a general formula of ln of x. X has to be positive. So we must have ln of a positive number. Ln has to be x has to be greater than 0. We must know that ln of 1 is going to be equal to 0. Ln of e is going to be equal to 1. These are just logarithmic properties. And x has to be a positive number. Now, anything inside our x values is an expression. It could be x plus 1 divided by x squared minus 1. It doesn't necessarily have to be just a variable. It could be anything. And in our case, we have a division. We have x plus 1 divided by x squared minus 1. X plus 1 divided by x squared minus 1. This has to be greater than 0. And also, let's make sure that this division is actually possible. So we cannot divide by 0, which means that x squared minus 1 cannot be equal to 0. Which means that x cannot take the values of 1 or minus 1. So x cannot be plus minus 1. Now, if x cannot take these values, we must make sure we do not include them in our domain. So once we find out that the domain has all the values except 1 and minus 1, and such that this expression, this division over here, is positive, let's put them on a table and see what values we actually get. So we have x plus 1 divided by x squared minus 1, which means we have x plus 1, we have a division by x squared minus 1, and we will have a final result. So let's make it as a table like that. Now we have critical points. We have the points of minus 1 and 1, which we cannot include. Minus 1 and 1. But anything in between we can give values. So we will give values in between that. In between that range. Like that. Between minus 1 and 1. And so on. So let's see what we get. If we take a value less than minus 1. So let's take minus 2. Minus 2 plus 1 equals to minus 1. That's a negative value, so we'll put a negative sign over here. 1 divided by x squared minus 1. Well, if we take the value of minus 2, we would have 1 divided by minus 2 to the power of 2 is 4. 4 minus 1 is 3. 1 over 3 is positive, so we have a positive value. A negative number divided by a positive number equals to a negative number, so the result is equal to a negative number. And let's put the result as x plus 1 divided by x squared minus 1. Now what happens at minus 1? Well, at minus 1 our division is undefined. We have x plus 1 minus 1 plus 1 would be 0. But then 1 divided by minus 1 squared minus 1 would be 1 divided by 0, and that's undefined. So undefined. If we have an undefined term, the whole thing would be undefined. Okay, so at minus 1 we take care that it's an undefined value and we cannot use it. What happens between minus 1 and 1? Let's take a value like 0. 0 plus 1 is a positive number, it's just 1, so we put a positive sign. 1 divided by 0 squared minus 1. 1 divided by minus 1 is a negative number. And then the whole result is going to be negative. Positive value divided by negative value gives a negative value. What happens at 1? Well, 1 plus 1 is going to be positive, but then 1 divided by 1 squared minus 1 is going to be undefined. And as a result, again, we have undefined value. And what happens above 1? Let's take a value of 2 as an example. 2 plus 1 is 3. That's a positive value. 1 divided by 2 squared minus 1. That's 1 divided by 4 minus 1. 1 over 3. Again, a positive value. And as a result, we have a positive value. Now look, this is the expression under the logarithm. And our function is the logarithm of the following thing. So if our function is f of x equals to ln of x plus 1 divided by x squared minus 1, and we said that this expression must be positive, we're looking on these ranges to see where the expression is positive, and it is positive only here when x is greater than 1. So our possible values are from 1 until positive infinity, and that is our domain. So let's write that once again because it's an important result. The domain of our function, the domain of f of x equals from 1 until positive infinity. Okay, that's our domain. What is going to be our range? So basically, if we take our function itself, ln of x plus 1 divided by x squared minus 1, what is going to be our results? Well, our values start from 1 point something. Look, the bracket is round. 1 is not included, because if we include 1, look in the table, if we include 1 we get an undefined result. If we include 1 we get an undefined result, and we don't want that. So the value next to 1 is possible, and that will be a number slightly bigger than 1. If we get a number slightly bigger than 1, so if we get a number that's approaching 1 but not taking the value of 1, well, look what happens. We would have a number over here, 1 plus, let's say 1.01, that's 2.01 divided by 1 point something to the power of 2 minus 1. Well, the difference between a number slightly greater than 1 and 1 is going to be a decimal. It's going to be a very small number. If we divide any number by a very small number, if we divide by a very small number by a very small number, we get a very large number as a return. Put it in your calculator. Just check what it means to divide 1.4 divided by 0.0001. You'll see that it's approaching a large number. Put even a smaller number in the denominator, you'll get even a larger number. So that means that our function, our f of x, would approach infinity, would take larger and larger values as x approaches to 1. So that's one case. What's in the second case? In the second case is that we can take values up to infinity in our domain. So if x goes towards infinity, if x becomes really large, well, we have in our numerator x plus 1, so we have, let's say 1000, x would be 1000, 1000 plus 1, that's 1001, divided by 1000 squared minus 1. Well, we would divide by a very, very large number. So if we divide by a very, very large number, the whole division over here would be a decimal, right? If we divide, for instance, 1 by 1000, that's 0.0001. Well, the same here. If we divide any number by a very large number, we would get a very small number in return. So we divide by a very large number. But now, one thing to pay attention to. We divide by a very large number. We get a fraction that is a decimal. So we get a decimal as a result. But then we want to know what is the logarithm of a decimal. And I encourage you to put it in the calculator right away. What is ln of a decimal? What is ln of 0.001, for instance? Well, it's a negative number. That's a negative number. And the smaller the input is going to be into our logarithm, the more decimals we have over here, the more negative our logarithm is going to be. So as a result, the function will approach a very negative number. In other words, it approaches negative infinity. And what did we find right now? We found the range. We found the values that we get as a result from putting in the domain into our function. So the domain was from 1 to infinity. The domain of our f of x, equals to 1 until infinity, and the range of f of x, the values that we get out of this, is from minus infinity until positive infinity. That's it for this video. In the next video we'll actually solve for the inverse.